Morning. Today we're going to be talking about section 7.2, which is our triangle congruence theorems. So we're going to have 4 theorems that we talk about today, and these are going to become really important next week as we start to move into our triangle proofs. But all 4 of these theorems work in a similar way. What they're going to tell us is if we have a specific set of information that we know between 2 triangles, then we'll know that those 2 triangles have to be congruent. Okay? And so there's essentially 4 different sets of information that we could have that would tell us that. And those are the 4 theorems that we have. So we're going to go ahead and work through each of these and make sure we understand what each one says. And then on the back here, we're going to do a couple examples of deciding whether 2 triangles are truly in fact congruent. Okay? So our first one here is what we call the SSS triangle congruence theorem, also known as side, side, side. Those S's are standing for side. So you could call this the side, side, side triangle congruence theorem. Okay? But what it says is that if I know that 3 sides of 2 triangles, I'm going to abbreviate and use our triangle symbol there, are congruent, and again I'm going to use our congruent symbol, then the triangles themselves are congruent. Okay, so essentially what this is saying is if I know that I have 3 pairs of sides that are the same, one from each triangle, that's how I make those pairs, then I know that the triangles are going to be congruent. Okay? Which seems pretty straightforward, but the fact is that's enough to tell us that they are congruent. We don't have to know anything about the angles, and that's going to be important because we can then say that all the angles are also the same, and if I asked you for a missing one or something like that, we could find that. Okay? So let's go ahead and draw a picture here. I'm going to draw 2 triangles that are roughly the same. Okay? I'm going to say that these are congruent, and we'll know that here in just a second based on how I label it. So I'm going to say that I have 3 pairs of congruent sides. So I'm going to say that's my first pair. I'm going to mark that they're the same with little tick marks. I'll do the same thing with this other side here. I'm going to use 2 tick marks there because those are congruent to each other, but they may or may not be congruent to this first side that I labeled. Okay? And then my third side is going to get 3 tick marks because, again, it may or may not be the same length as the other ones, but they are in fact going to be the same as the one from the other triangle. Okay? Knowing this information allows me to say that these triangles are congruent. Okay? And if we think back to what we talked about a couple days ago, that would then mean that congruent parts of these congruent figures or corresponding parts of these congruent figures are congruent as well. So the angles would match up, the other angles I would have between this, I would have collinearity, all of that stuff still applies. Okay? So let's go ahead and move on to our next one here. Our next one is SAS. So again, S here is standing for the sides, and the A in the middle is the angle. Okay, so if I have an angle between 2 sides, then I could also say that they're congruent. Okay, and so to put that into words here, we're going to say if 2 sides, again really 2 pairs of sides, with the included angle, talk about what that word means in just a second. Angle, again, of 2 separate triangles are congruent, then the triangles are congruent. Okay, so the real new word here is going to be included. So included is another word to kind of say in between. So if I'm talking about an included angle, that is the angle that's formed by the 2 sides that I'm talking about. So it's the angle in between 2 sides. That makes a little more sense if I start to draw a picture here. So I'm going to draw a slightly different triangle here, but again 2 relatively congruent triangles. Again, I'm going to start with my 2 pairs of congruent sides, is what I have here. Right. And if I look, my theorem is side, angle, side, and that's the order that I need to have things. So I can't have side, side, and then an angle. I need the angle between my 2 sides. So I would need to know that this angle, in this case up here at the top, is congruent between my 2 shapes. If I knew that, then I could say that these 2 triangles are congruent. And again, then CPCF works, and we could find the other angle, the other side, whatever we were asked to find. Okay? Angle, side angle is our next one, so ASA. Okay, again, angles and sides, but now this time the side is between the 2 angles. So we're going to say if 2 angles with the included side of two triangles are congruent, then the triangles are congruent. Okay, so if I have two angles with the side in between, that is also enough information. So let me draw, we'll go to a right triangle this time. Again, the triangles that I'm drawing are just examples. It's really more the information that we're talking about within each triangle. Okay, so let's say that I'm told my top angle here is congruent to the top angle on the other side. And this bottom angle, I'll mark it with two arcs here, is congruent as well. Okay, then according to this theorem, if it is truly going to be ASA, then I need to know the side in between is also congruent. Okay? Now this one, the order is not quite as important, because if you look at the next theorem is angle, angle, side. So this is telling me the side can be on the outside as well, but it is a different theorem. Okay? So we do have to make sure we're at least still identifying the correct theorem that we're using, even though they still probably means that they're congruent. Okay? And what we're going to talk about, there's one caution here with this one that we need to make sure we talk about. Okay? So let's go ahead and start with angle, angle, side, which says that if two angles with a non-included, which is the opposite of included, meaning it's now not between the two angles, side of two triangles are congruent, then the triangles are congruent. Okay, so again, very similar to angle, side, angle, but now the side is in a different place. It's a non-included side, which means it's not in between my two angles. Okay, so if I draw this out here, I'll go back to right triangles again. Let's do that one a little bit big. I'm going to go outside the box just slightly here. Okay, if I still have those same two angles, what I'm calling the top and the bottom angles here, it is marked there as well. So I have two angles that I know. In order for it to be angle, angle, side, I have to know another side that's not in between. So in this case, I'm going to use the bottom one. Okay, now this is where we have to be very careful. Whatever angle the side is next to, or it's adjacent to this angle, the other triangle, that same side that I'm congruent to, still has to be adjacent to the same angle. Okay, so I'm going to switch to a different color here. I don't want you to write this down, but I want to show you something. That if I had this side and I use what would be my vertical side here, I would still have two pairs of angles and a pair of sides that's non-included, but this would not satisfy our angle, angle, side theorem. Okay, the issue here is the angle that I'm between. Essentially here I would be saying angle, angle, side, where over here I'm saying side, angle, angle. Okay, which typically that order doesn't matter, but because this side and angle are going to be attached to different angles, we do have an issue here. Okay, so that is just a quick warning here, and I'm going to put that down here on the bottom as well. So I'm just going to put a little arrow over to this picture, and I'm going to say be careful of where the side is located in terms of the angles. Okay, so again, I have to be next to the same angle. I cannot switch which angle I'm next to. Okay, so those are our four theorems. Okay, so again, we have side, side, side. We have side, angle, side. We have angle, side, angle, and angle, angle, side. Okay, now I do want to quickly talk about where these things are coming from. So these are triangles, which means we have basically three pieces of information that we need. And we're using sides and angles. Those shouldn't be necessarily a shock to you. Okay, what I want to talk about though is the ones that we don't have. Okay, so we had a side, 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 but we don't have angle, angle, angle. Okay, so I'm going to list these down here. These ones are no good. So angle, angle, angle. Okay, and the reason this one doesn't work, we'll talk about this one a lot kind of second semester, is this doesn't tell you at all how big the triangle is. Okay, so if you want to think of an example that wouldn't work for this, create a triangle and just shrink all of the sides down by half, and the angles would still stay the same, but the sides are now smaller, so they're no longer congruent. This will end up being what we call a similarity theorem. Okay? The other one that we don't like is side-side angle. Okay? This is one we're going to talk about more towards the end of this chapter. There is a way to make this theorem work, but in general it does not. So side-side angle is no good. The way we can always remember that this one doesn't work is if you flip it around from the way I wrote it, you get a bad word. And as of now, we cannot have bad words in math. So that one's no good, and neither is angle, angle, angle. Okay? So good ones just to know that those two are the ones that don't work. The other four combinations will always work. Okay? And with angle, angle, side here, the side could come on the front, and we would just look at it the other way then. Okay? Alright, let's go ahead and flip over to the back here, where we have 4 problems that we want to go ahead and work through. So each one of these is essentially have 3 pieces. That's why we have A, B, and C labeled here. We have to first decide, are these triangles actually congruent? Then we have to justify with one of our triangle congruence theorems why they are congruent. Okay? So in other words, if we're going to say they're congruent, one of those 4 theorems that we talked about in the front has to be true. And so if they're not true, then it's not going to be congruent. Okay? So essentially we're working with the information that we have in the picture, and we need to figure out, is that enough to say these are congruent? If we can say they're congruent, then in C we're going to indicate the corresponding vertices. Okay? The way we're going to do that, and this is the way sometimes you'll see it in your homework or on a quiz, is to write the congruence statement. Congruence statement. Okay? So if you see that, that's the same thing that we're going to do there. Okay? If it's not congruent, we're just going to say not enough information, and we won't do that part. Okay? And that's really for B and C. Okay? So let's go ahead and start here. We're going to look at number 1. So number 1, I have 2 triangles here. I have A, B, C, and D, F, E. Okay? And I have 3 pieces of information labeled. I have an angle at the top and an angle at the bottom. This one's labeled as 90. Same thing over here. I have an angle of 90 and an angle at the top. So these 2 have to be congruent. I also have a side that's congruent. Okay, so if I look now, I have 2 angles in a side, and if I go back to the front, we had our 4 theorems. Actually, over here on the side, I'm going to list them. We had side, side, side. We had side, angle, side. We had angle, side, angle. And we had angle, angle, side. Okay? If I look right now, I have 2 angles, and I have a side in between. Okay? So that's an angle, a side, and an angle. Or I'm satisfying this third theorem here of angle, side, angle. So we are going to say that these are congruent. So we're going to say yes, they are congruent. And our reasoning or our justification there is going to be angle, side, angle. And we are given that information, and that is enough for us to know. Okay, at this point, I need to write my congruent statement. So that is where I'm going to say that one triangle is congruent to another triangle and list the vertices in order so that they correspond to each other. Okay? To do that, take one of your triangles. I'm going to start with ABC here and just list out the letters that are in that triangle. It does not matter the order you put the first one in, okay, because I just have to get in order first. The second one I need to make sure I match up. So angle A, if I look here, is marked as one of my angles, matches up with angle D. So D has to be the first letter when I list out the second triangle. Angle B is my 90 degrees. My 90 degrees and my second one is F, so F needs to come next. And then finally, the third letter is the C. That is going to be E in the second triangle. Okay? So notice just because I list the first one in alphabetical order doesn't mean the second one is either. We have to match up all of these vertices as we go. So A and D, B and F, and C and E. Okay? Let's go ahead and move down to number 2 then. Number 2, I have an angle here. Looks like I have one angle, and I also have 2 pairs of sides. Okay? Now this is a very tricky one. We have to make sure that we satisfy the theorems that we have. Okay, and if I look here, my angle is between my 2 sides, so I would have a side, an angle, and a side. And if I look up here, it's off your screen a little bit there, side, angle, side was one of my theorems, so I'm going to go ahead and use that one. So we're going to say that yes, these are congruent by side, angle, side. So part B is side, angle, side. And just like the first one, I'm going to start by listing one of my triangles. I'm going to start with X, Y, Z here. X, Y, Z. And that's going to be congruent to our other triangle. If I look, angle X is my marked angle. That has to go to T. So I'm going to start with T. Then angle y, I don't actually know which angle corresponds to y, but I can use the side here that's marked. So xy is my first two letters. So I know I'm got to go from t to another angle, and that's my side marked with one tick mark. So from t to go across the one tick mark side is to go to r. So my second letter must be the r. And then my third one is just the one I haven't used, which will be the s. So triangle TRS is going to be congruent to XYZ. Okay. Next one here, okay, we did throw one on here just to make sure we're not saying they're all congruent. If I look here, I have an angle, an angle, and an angle. That's angle, angle, angle. So that's the theorem I would be working with. However, angle, angle, angle is not one of our theorems, so we would say that these are not congruent. Okay, because we don't have angle, angle, angle. And we were told in our instructions that if we had one that's not, we just have to say there's not enough information. Okay, and this is a good point to make here. These still could be congruent. Okay, if we look at these pictures, they obviously look very, very close. However, the information that I'm told here is not enough for me to say that they are. As soon as they start to tell me some sides that are congruent, then I might be able to say that they are. Okay, but just based on the angles that they give us, that is not enough. Okay. Last one here we're going to talk about is number 4. So with number 4, we have one pair of its sides, marked with just one tick mark, and I have two pairs of sides. So right now I'm looking at side, but I'm actually missing a third piece of information. Okay? And this is where we have to be a little bit careful about what we do. There is a third piece of information here, and it is the side that MO is our third congruent pair. Okay? If I look here, I'm going to be using triangle MLO and MNO. And if I look, MO is shared between both of those. Okay? If you remember back to when we talked about our congruence theorems, we had several properties that deal with equivalence and congruence. And one of them was that reflexive property, that if it's the same thing, it has to be congruent to itself. Okay? And so this is the reflexive property showing up right here. That this is congruent to itself. MO is congruent to MO. That gets me my third side so that I can say side, side, side. And that's the theorem I'm using. And since that is one of our theorems, we can say that yes, these are congruent. And once again, I'm going to start with my triangles. I'm going to actually list MO first because I know MO shows up in both my triangles, which will just make it easier. And then the third side, or third angle. Okay, same thing for the second triangle. I'm going to start with MO because I know that matches up with itself. And then the other angle that I didn't list, okay, which is then the N. Okay, so this is kind of the examples that we're doing. Okay, your homework today is going to be going through some of these and actually trying to decide, based on the information that it gave you, can we say that they're congruent? Okay, and the biggest thing I can tell you is you have to use the information that I'm giving you. Okay, we can't assume that sides are congruent because they look the same or angles are the same. The only way I can assume information that's not told to me is if it is clearly something that we can assume, like the side MO has to be the same. I can't have two different lengths for MO. Okay, so be careful of stuff like that. Be careful of the two theorems that we don't have, which again, we're over here, angle, 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 and side, side, angle. Okay, all the rest should be pretty straightforward. If you have questions, we will go over those tomorrow in class.